So, quick survey of the room, just for demographics. I realized last night that this isn't really a dedicated Android event, it's just run by an Android group. So, how many people here have never worked on an Android app? Alright, a few people. Hopefully there's nothing really Android specific about this. If there is, I'll try to make sure I remember to explain it. And another question, how many people here are Android developers by profession and not just a hobby? Okay, a lot more people there. Okay, good, so that's good to know. All right, so stealing the web's best feature. I guess the question is, what is the web's best feature? I am not going to explain that for a while, so instead, I am going to spend a lot of time talking about business logic. So, actually, hold on. I have this set up wrong. I don't have any of my notes. Much better. All right, business logic. So, term you've all heard a lot before. What is it? It's kind of in the name. It's logic that's related to your business. So it's nothing related to the architecture of your app. It's things that your product team or your design team determine, and not the decisions that you as a developer make. So some examples of this are, what is a valid username? Generally 4 to 20 characters, alphanumeric with dashes and underscores. Another example, is your password secure enough? So at least 8 characters, 1 lowercase, 1 uppercase, 1 number, 1 special character. We all know the practice for choosing a secure password, I hope. When do you nag for a rating? So this is something that you've probably implemented, not of your own free will. Somebody's told you to do this, where in your app, you nag the user to give you a 5-star rating. So when do you do this? Do you do it after a week? Do you spend a little more time implementing this and do it after 3 successful payments? You want to make sure that the user is actually happy with the app before you ask them to rate it, or else they're going to give you 1 star. What is the maximum length of a tweet? So obviously the answer is 140 characters, except that's not really true anymore because they just changed that so that there's a whole variety of things that don't actually count towards the character limit anymore. So it's 140-ish. How do you render your data? So maybe you have some text on the screen that can be green, can be red, can be gray. What determines what color it is? Show an appropriate icon depending on the state of something. You probably map an enum to a string somewhere. How does your referral program work? So this is one of those other things that nobody likes doing, but you have to do it for your product to be successful. It's growth hacking. So do you pay out $1 per successful referral? Do you pay out $10 after somebody's successfully referred 5 people? So all these are examples of business logic, and they're all to varying degrees of complexity. So now the question is, where does this business logic live? Generally, there's 2 parties involved. You have the client and the server, so your options are pretty limited. However, something to keep in mind is that when you think about the client, really it's like multiple different platforms that you're supporting. So for us, we support Android, we support iOS, and we have a web app. So if you have an app that doesn't talk to a server or doesn't talk to a server that you own, then the answer is very easy. You stick it on the client, because that's the only place you can put it. But for everybody that does have this option, let's talk about the different places it can go. So, the client. So when the business logic is in the client, you bake the logic into your APK. And the logic is fixed for a given app version. So in the example of username validation, the length check of 4 to 20 characters, that would be hard-coded into your app. Let's look at the pros and the cons. So you have a fast feedback loop. The logic is executed locally on the client, so you can do things in real time as the user's typing, like you can update the status of buttons if they've entered a username that's in the valid range. Downside is that this requires an app update to change, so anytime you want to change this logic, you have to ship a new version of the app. And The problem here isn't that it's work, it's that your users don't update right away. So if you haven't checked the distribution of what version of your app your own users are using, I strongly encourage you to go do so, because you'll find out that there's users still using a version of the app that you released a year ago. And we've actually implemented basically a kill switch in our app. The reason we did it was so that if we ever released a bad version of the app, or there's an incompatible upgrade to kind of new logic that we're running, then we can get users to upgrade. But we've started using it because people just don't upgrade the app, and we want to get them off of it so that the server can remove code that's a year old. So all of this code is duplicated across all the platforms. Your Android team has to do it, your iOS team has to do it, and your web team has to do it. And when you duplicate this code, you have the increased probability of introducing bugs. And you have a potential mismatch between the platforms because they're all doing this separately. All right, so let's talk about putting it on the server. When the code's on the server, the client doesn't care. The bare minimum that your client would do in this case is just check that the input is non-zero in length. And then just sends it to the server, and the server returns whether or not it's successful or not. So the logic here can be updated independent of your app updates. Your server just pushes new code, and the app gets these new logic changes. And now all your platforms are in sync because the client hasn't really written anything. So the downsides here are you have a slow feedback loop. So every time you want to run this code, you have to make a request to the server and wait for a response. So you can't do anything in real time in the UI. And the client must be online. All right, so we talked about putting it exclusively on the client and exclusively on the server. What happens if we split it up between the two? So here, the client bakes in the variable logic, and the values are provided by the server. So for the example of a username min max check, the client would know how to check that the username is within some range, but the actual values that it's checking are coming from the server. And this is also where you would do feature or experiment flags. So for something like this, the client would implement two completely separate code paths, and the server would just provide the toggle for which one to follow. An example for this one is like Firebase remote config. So there's a Firebase CodeLab in the afternoon. I assume there will be some talk about remote config. It's pretty handy. All right, so we have a fast feedback loop again because the logic is being executed on the client. The logic is updated independent of app updates, and all your platforms are in sync. However, this is only true if you don't add new variables to the equation. So anytime you want to add a new rule, the app requires an update, and once again, your platforms can fall out of sync. So what do I mean by this? So for the username check, let's say the client only cares about the length of the username, and you make the decision that you want to also check the characters. So now the client needs to update its logic so it knows to check any new config coming down from the server for valid characters. And once again, you've duplicated a bunch of code across all your platforms. And this is now a lot harder complexity for the client because you're just writing so much code. So in summary, if the business logic lives on the client, then your PM is sad because logic is expensive and slow to change. Anytime you want to change something, you have to build a new version of the app, you have to ship it out to the store, and chances are it's going to be a minor change that's not going to force you to release the update out of schedule, so it's going to be weeks before you release that update, and then it's going to take like a year for all your users to actually get that change. If the logic lives on the server, then your users are sad because now your app is very slow, or it seems very slow. And if you split it, then you, the developer, are sad because you're just writing so much code. So I'm going to take a minute to talk about hybrid apps. Hybrid apps are basically just really advanced web views. So for this, the server will send down HTML, CSS, and JavaScript, and the app will try to look and behave like a native application. So some example frameworks for this are PhoneGap and Cordova. So if you are the sole developer at a company and you've been tasked with building the Android, the iOS apps, and the server for your company's new smart Internet of Things kitchen appliance, and you have like 3 months to do it, then this is probably what you should use because it's really quick and easy. But if that's not the scenario you're in, then chances are you're going to want to stick to a native app. And there's a lot of reasons for that, but generally the apps are just a lot better to use from the user perspective. So this isn't completely wrong, however. I didn't put this up here just to say mean things about it. Let's take a closer look at what these are. So as I said, there's HTML and CSS to run the UI of your app. There's JavaScript for the logic, and there's extra Android bits for integrating with things like Bluetooth. So the things that I said are not great. That's the UI part of it, it's HTML and the CSS. So you decide that you're going to make a native app, so you don't need to deal with this. And because you're writing a native app, you don't need to deal with the Android bits. So what we have left here is JavaScript for logic. And some of you may think, oh, JavaScript, it's awful. Why would you ever talk about that? So the awful part about JavaScript is the parts that deal with the DOM. We're not shipping HTML, so we don't have to care about the DOM. All we have left is a perfectly fine scripting language. So let's talk about JavaScript. Who can run JavaScript? The web. Absolutely. Web can run JavaScript. iOS. iOS can run JavaScript, but out of the box, they have a JavaScript engine built into the OS that you can use. The server probably can use JavaScript. If you're using some obscure language on the server, then maybe not, but our server is written in Java. There's plenty of libraries you can pull in to execute in JavaScript. And then Android. What about Android? There's nothing built in natively. This would be a really boring talk if I told you no, Android can run JavaScript, and I just moved on to something else. But yes, there's this cool library called Duct Tape Android. So Duct Tape, what that is, it's a compact, embeddable JavaScript engine written in C. We have nothing to do with that. I don't ever want anything to do with that. Duct Tape Android is Duct Tape, which has been packaged to run on Android with JNI bindings. All right, so let's write some JavaScript. So simple example, back to username validation. So here's a function that takes in a username, and it returns true if the username is within 4 to 20 characters. We can make this a little bit better. We can return an error message if the username is invalid, and return null if it's valid. So, setting up Duct Tape on Android, you just call ducttape.create to get a new instance, and then you call this evaluate method. And the first parameter here, that's your JavaScript. It's a string, so that would be the function that I showed you on the previous slide. And the second parameter here, that's just an optional name that you can use for stack traces. So if your JavaScript throws an exception, then Duct Tape Android will synthesize the stack trace, and if you've inserted multiple scripts into Duct Tape, then it's handy to know which script is actually throwing. So we are going to call evaluate again to run this method. We're basically just crafting a JavaScript method call here, validate username. This is kind of gross, and it's probably buggy. You may notice that if the username, for whatever reason, if you allow it to have a quote in it, this is probably going to throw because you're not escaping it. And also, evaluate just returns an object. It's up to you to cast it to whatever you're expecting back. So we can make this better. This is an interface that we ideally like to use for validating username. It's called validator, has one method in it, takes in a string and returns a string, which, if you recall, is an optional error message. And then if we just slightly tweak the JavaScript that we provide so that it matches this hierarchy, we have a class, and then we have this method inside which matches the method name. Then we are able to use Duct Tape to create an instance of this validator for us. So we call ducttape.get. The first thing we pass in, this is the global JavaScript object. I probably should have named these differently so they don't all just say validator. But so this JavaScript object is what you defined in your JavaScript, and then this is the Java interface that you want Duct Tape to implement for you. And it'll give you an instance of validator, which is hooked up to proxy down to the JavaScript. And then we can take this gross piece of code here and just replace it with this nice method call. And so this is much better, and now you are able to pass around this validator object instead of your duct tape. All right, let's go the other way. Let's call Java from JavaScript. Now, why would you want to do this? So one really great example is for logging. So right now, your JavaScript is this black box where you call into it and you hope that you get a result out, and you have no idea what's happening underneath. You can't debug through the JavaScript, unfortunately. So you can hook it up so that whenever your JavaScript wants to log something, it gets proxied to your Android logs. So we have this interface, JS logger. Just for the simplicity of this talk, it only has one method called D, which is for logging debug messages. So you are going to create an implementation of this interface. This is a very simple one. It just takes the message and it proxies it through Timber, which is a great Android logging library that you should all be using. And then instead of get, we're going to call set on Duct Tape. The first parameter is the global JavaScript object that you want to be created. This is the object that your JavaScript code is going to be trying to call to. Second is the Java interface you defined, and the third is the implementation of the interface that you can see above. Then in your JavaScript, you can just access this new JS logger class and log some messages. So let's look at a slightly more complicated example. Let's say you have JavaScript that's driving some of your UI, and you want to be able to format some dates. So how many people here have their phones set to 24-hour clock instead of 12? A lot of people. So how many times have you opened an app and it's displayed a date in 12-hour when your phone is set to 24-hour, if you've noticed? Not many people notice. I don't know if that's a thing you notice, but I mean, it happens because the app just specifies how it wants to format the date, and it ignores your setting. And we'd like to make that actually obey what you said. So we have this interface called date formatter, as a method called format, takes in a time in milliseconds and returns a string. You create an implementation of this, which calls into this very handy format date time method on date details, which formats the date according to the user's preference. And then once again, you call set to hook that up. So now your JavaScript is able to call out to Java and format the date using the user's preference. All right, let's get crazy. Let's have your JavaScript read and write to persistent storage. So you have an interface called storage. Right now it just deals with strings for simplicity. You can make this typed if you want. You can have like a read Boolean and a write that takes in the Boolean. I'm not going to show you the implementation, but this is a thing you can do. You can have your JavaScript write to Android shared preferences or a SQLite table if you're crazy. Yeah. So let's look at the pipeline that we have set up in cache for setting up our JavaScript. So we ship a copy of the JavaScript in our APK. This is a snapshot of what the JavaScript looks like at the time that we build the app. And this is always available to us because it's in the APK. And then our server, it has a fresh copy of the JavaScript that's constantly being updated. And what we do is at the start of the session, we call the server, we grab a copy of the JavaScript, and we save it to disk. And now we use that one going forward instead of the one that we had shipped with. Now, if this might seem a little scary to some of you because we are downloading code from a remote place and we are executing it in our own environment. It's very dangerous, but we rely on the fact that the connection to the server is over HTTPS, and we are also using certificate pinning. So the app is guaranteed to only be talking to our server and no other server. And we save the JavaScript in the app's kind of private storage on the phone. So this isn't a very complicated pipeline to write, but unfortunately, you currently have to write this. Ideally, we're planning to roll this into Duct Tape Android so you don't have to do it. You will just be able to give it kind of the local JavaScript you shipped and a URL for where you want to fetch it, and hopefully it'll do it all for you. It's currently not the case. Planning to fix that eventually. So I said we ship a copy of the JavaScript in our app. We do this using a very, very simple Gradle task. It's like 5 lines of code. So we have a task called update script, and it knows the remote location of the JavaScript, and it just downloads it and saves it to our assets folder. So you just type Gradle W update script, and we have a new copy of JavaScript that we can check in. And this doesn't happen as part of our build. We do this manually and we check it in because we want to be able to, when we check out an older copy of, or an older commit of the app, we want to make sure that we are running the JavaScript that was on the app at the time. All right, so how does this compare to the client and the server business logic? So once again, we have a fast feedback loop. The logic is being executed on the client. The logic can be updated independent of app updates. The server just deploys a new version of the JavaScript. Eventually, the app will go and fetch it, and now we are running the new hotness. All the platforms are in sync. The downside here is that it's medium client complexity for the first integration you write, because you have to kind of build that pipeline. However, any future integrations you want to add, it's just a few lines of code, as you saw. You just bind to a new method in JavaScript. And also, as I said, hopefully that whole thing is going to go away, and it's going to be easy to do the first one in the future. All right, so let's talk about why we went down this path. We didn't do this just so you could validate a username and update the logic that validates usernames. That's a lot of work just to do that. So this is the activity screen in Square Cache. This is a list of all of the payments that you've sent and received. And right, so we want to sync these payments with the server. So the first version of this that we wrote, we basically call the server, we say, hey server, can I have my payments? And the server says, sure, here's all your payments. Cool. And then 5 minutes later, we call the server again. Hey server, I'd like my payments, please. And the server says, all right, here are all of your payments again. And this is kind of fine at the start, but 3 months later, this is kind of what this starts to look like. You've accumulated just a ton of payments, and now every time you call the server, it is sending all of your payments back, and before it sends them back, it has to go and look at all of them. It's probably doing some complicated transformations on them, and it's just high bandwidth and high server load. I go back. Sorry, you're going to see that crazy animation again. All right, so let's come up with a new syncing model. So the first part of this is the same. We call the server, we say, can I have my payments, please? And the server says, sure, here's all your payments. However, the difference here is that it also gives us a sync token, and we hold on to that. And then 5 minutes later, we call the server again, say, server, can I have my payments, please? And here is the last sync token that you gave me. And the server says, you're up to date, nothing's changed. And then a day later, call the server again, got my payments, here's the last sync token you gave me. And the server says, all right, so 2 of the payments I gave you last time have been updated, and you have a new one. And here's a new sync token. So this is great. It's not very hard, but it just makes everything so much better. So, you know, what's the problem? Why do we need JavaScript here? So here's the problem. These are all the screens in our app that show payments. And on Square Cache team, for numerous reasons, some I agree with, some I don't, we just love server-driven UI and server-driven text. So that name, that comes from the server. That description, that also comes from the server. That title, that's from the server. that text is also from the server. That little status message there, that's from the server. This button and that button, I spent a lot of time writing those buttons. I'm very proud of them. It says request and pay. However, this title's from the server. That icon is driven by the server. That's server, 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 server. So basically, 95% of the things on the screen are driven by the server. And this changes quite frequently. So we've come up with this model where the server only sends us payments when they change or when there's new ones. And we've introduced this thing where the payments are always changing. So every time we call the server, if a string has changed and all your payments need to come down again, and we've just basically invalidated this cool safety model that we come up with. So how can we solve this? We have server-driven text. So we keep this same get payments protocol, and then we also add this new one called get strings. So we split out the strings. We call the server, it gives us a map of strings. They have an ID, they have a string, and then instead of having the strings built into the payment, it's just IDs that reference strings to this map. I mean, it's not ideal, but I guess it works, right? Except it doesn't work. So we have this message here. Your cash has been sent to your bank account. It will be available by tomorrow. It seems fine at first until you realize that it says by tomorrow. There's time involved in this now. So 24 hours from now, this string is going to change. And the thing about the banking industry and payments is that it's just really bad. So when we pay out money to a bank account, we call the bank, not by phone, by internet, and we tell them, deposit $50 into this bank account number, and the bank says, all right, cool, I'll do that eventually. And then, 2 business days later, the money shows up, and we have no idea that it's actually showed up. We just assume it has. So, as far as the server is concerned, the payment in this state and the payment 24 hours from now are in the exact same state. Nothing has changed. And our whole server has been built around this assumption. And changing this so that we have time that moves payments through states requires like a complete infrastructure rewrite. And we can't do that. So how do we sync this? All right, so we still have this get payments. We have our stupid get strings thing. Now, let's just say that instead of string being one thing, it's now a map where the key is the time that a string takes effect at. This is really gross. We actually kind of talked about this seriously and then decided, no, this is stupid. We're never going to ship this. Like, I'll cry myself to sleep every night if this is code that ships to our customers. Because this doesn't scale. So, how do we do this? Well, we kept that cool get payment syncing model, and then we store them to the database. And every time we want to render a payment, we proxy it through JavaScript before it gets to our UI. And then, as I said before, this JavaScript can be swapped out on the fly. So in the JavaScript, it has all the strings that we want to use. And most importantly, JavaScript is able to tell the time. So if you call into it on one day, it can give you a different string if you call into it 24 hours later. So all of our problems are solved. We now have this completely server-driven UI that is very, very easy to sync and lightweight. So an important thing to call out here is what we actually pass into the JavaScript. So we could come up with this contract where, given a payment, the JavaScript expects these 5 fields from it to be able to render data. But the problem here is that if the server ever wants new information that it wasn't already provided, then we need to roll another app update. And we've spent all this time trying to make it so that we don't have to do this. So instead, inside of the payment, we have this one field called JS data. We have other fields, but this is the only one that matters. It's called JS data, and this is just an opaque blob of like the string that the server hands down that we just store and relay to the JavaScript when we need it. We don't look at it, we don't care about it. So in the rare case that the server requires additional information that it didn't already have, then it's able to resync all the payments and send new data to this JavaScript. All right, so this is fantastic. whenever we want to update this business logic in our app, the server updates to JavaScript, and all of the client versions since we built this feature are receiving the new logic. So I'll leave you with some Duct Tape Android pro tips. Duct Tape is mutable, so be careful if you're sharing it between threads, or better yet, don't share it. We have a dedicated looper that we run all of our Duct Tape code on. And Duct Tape is still using ES5 and 5.1, so you don't get any of the fancy new 6 features currently. So, what is the web's best feature? Is it JavaScript? No, absolutely not. JavaScript is not the best feature. The best feature is that whenever you deploy a change on the web, all of your users receive it instantly. Like, you don't have a long tail of users running year-old versions of your website. So with JavaScript and Duct Tape and Android, hopefully you're able to use this. So this isn't a solution for everybody. I mean, this is a lot of work if you have a very simple and isolated use case, but I encourage you all to consider it when you're thinking about where all your business logic should be living. Yeah. Thank you. Any questions? Yes.
I just wanted to know, I've never used the application. What happens if you're offline? Do you, if someone wants to do payment and they're offline, do you block the UI, or do you agree with the payment and later sync with the...
Right, so the question was specifically about Square Cash and what we do in offline if you want to send a payment. We don't support it, we just scale it. We've talked about it a lot, there's a lot of complications involved in that, so. Yes?
How do you feel about the Tape performance wise? Did you find that it's comparable to native code, or are you running enough code that you've got some bottlenecks, or?
Right, so the question is about Duct Tape performance. We haven't really noticed anything. I mean, so we're already talking to the database to get our payments out, so that's probably, like, we're already doing this asynchronously. So this extra time to run it through the JavaScript engine, it's not noticeable. We haven't done any benchmarks on it, but don't run it on a UI thread. That's the only suggestion I have. Yes.
If you test your application with different versions of JavaScript and your activity,
Can you repeat that?
how do you test your application?
So the Java, our question is how do we test it? The JavaScript is unit tested in the server code. So that part we assume is tested, and then, I mean, we just check it manually, but I mean, you can also write instrumentation tests on it.
When you expose new JS interfaces, you still have to update your app, right? If you add new
right.
features in the JavaScript, you still got to roll out.
Right, so yes, if you add a completely new feature, you do need to update your app to do it. That should, I mean, you already need to update your app to do new features anyway.
Yeah.
So, I mean, it's pretty rare for us to have to implement kind of a new JavaScript method call.
But you were passing a lot of data with that, was it JS data?
Yeah.
So that's how you stop from exposing new interfaces by just making some kind of
Right, so
data format that's kind of variable.
Yeah, so that JS data is how we are able to add new inputs into existing kind of pipelines that we have set up.
Okay.
And then if you have to add a new one, then you have to update the app. But I mean, I think we probably shipped that almost a year ago, and we're only recently, like now, working on the new.
But the JS data is kind of variable.
Yeah, that's changing quite quickly. Yes.
It's possible to do HTTP request from the JS engine?
All right, so making HTTP requests from the JS engine. Probably shouldn't be doing that. If you do, I mean, it's just as simple, like I talked about calling Java from the JavaScript. So you can set up that binding, and then you can make a synchronous HTTP call, and then return the results back to JavaScript.
When data is changed in the database, does it get updated on the client side automatically, or you need to
When it's changed on the client database, or
on the server database?
yeah, so that's part of the syncing model. Like the client is constantly just like pinging the server. It's like, do I have any payments? And then eventually the server will give us the updated payment if it's changed.
Sorry. Does Duct Tape support like any module systems like on JS? Can you import modules from a system like that?
So does Duct Tape support JS modules? I don't know.
Oh,
Maybe. All right, I think I'm out of time. So if you have any more questions, feel free to come find me later. I'll be around. Thank you.